The preparation of catalytic ink. Catalytic ink is a suspension used to form the catalytic layer of a fuel cell electrode, either anode or the cathode. To prepare it, the appropriate components must be selected. The catalyst layer is a porous structure composed of two main components: catalyst material where adsorption reaction and desorption process occurs, and electrolyte material, which in our case is proton conducting. To prepare an anode with a platinum loading of 0.2 mg per square centimeter on a 6.6 to 6.6 square centimeter electrode, you will need 80 mg of PT20 on C, 0.8 ml of deionized water, 1.6 ml of isopropanol, 0.8 ml of 5% Naphthalene dispersion. The proton conducting material usually stored in fridge. It is the second key component of the dispersion of proton conducting material, which consists of 5 weight % of solid electrolyte, in this case naphthalene, in a mixture of monohydric alcohol and water in a 40-60 ratio. And to calculate the mass of solid components, you have to use the next formula. Mass of solid component in milligrams equal volume of dispersion, in our case microliters, multiplied to density, according to the data sheet 0.92 to 0.94 gram per milliliter, and multiply to 5%. Second component, catalyst material. It is an example of catalytic material is PT20, a dispersion of a platinum nanoparticles on carbon support. The label PT20 indicates that the material contains 20 weight % of platinum. So, 1 mg of PT20 on C contains 0.2 mg of platinum and 0.8 mg of carbon. Let's take a closer look at what the catalytic material looks like. The catalytic material is weighted using the analytical scales, and it was already added to the glass bottle according to our ink formula 80 mg. Following our formula, we will now add 0.8 ml of deionized water. For this purpose, we will use an Eppendorf pipette. We set it to 400 microliter for safety reasons. We will then add 400 microliter twice. As the liquid components are all different, you must not use the same pipette for the next step. The third component is isopropanol, and 1.6 ml is added. You must use a new pipette to add 4 times 400 microliter. At this stage, we seal the mixture to mimic the standard situation in which Nafion dispersion is stored in a refrigerator, and to prevent alcohol components from evaporating from the mixture. When you are ready, add the final component, 0.8 ml of 5% Nafion dispersion. In modern catalytic layers, the ratio of electrolyte to catalytic materials typically ranges from 1:1 to 1:3. That is 1 part electrolyte to 1 of 3 parts catalytic material, and these two components are mixed in appropriate proportion depending on the number of samples to be produced, accounting for losses during layer deposition. All 4 components are in a glass bottle. The catalyst layer is to be formed by 2 of them. To obtain a homogeneous ink, 4 components are dispersed using an ultrasonic device for 1 hour with ice added for cooling.